Good day to everyone. This video I'm going to discuss about the topic special electrical machine subject in that unit 3 permanent magnet brushless DC motor. In that the topic of discussion is drive characteristics of permanent magnet brushless DC motor. So the different classification of permanent magnet brushless DC motor is single phase 1 pulse brushless motor, single phase 2 pulse brushless motor, 2 phase and 2 pulse brushless motor, 3 phase and 3 pulse brushless motor, 3 phase and 6 pulse brushless motor. Now first we'll discuss about the topic 1 phase winding and 1 pulse brushless permanent magnet DC motor. Here it shows the stator of brushless permanent magnet motor with one phase winding. It is connected to the supply through a power semiconductor switch. When the rotor position sensor is influenced by the north pole, the stator is excited and the rotor develops a torque. When the rotor position sensor is under the influence of the south pole, the transistor is in off state. So the rotor develops torque. Whenever the rotor position sensor is under the influence of north pole, the current, torque are approximately sinusoidally varying and the waveforms it is displayed here. Now the merits of this one phase brushless permanent magnet motor. So the merits, it uses only one transistor, one rotor position sensor is sufficient. Demerits, the inertia should be such that the rotor rotates continuously. The utilization of transistor windings are less. One phase winding and two pulse brushless permanent magnet motor. So here you can see the single phase, and whereas we are using two transistors. So in this type, the stator has only one phase that is connected to a 3-wire DC supply through two semiconductor switches. Here, in this, when the position sensor is under the north pole influence, T1 is in on state and T2 is in off state. The phase winding carries current from A to B. When the position sensor is under the influence of south pole, T2 is in on and T1 is in off. The phase winding carries a current from B to A. So the polarity of the flux setup by the winding gets altered depending upon the position of the rotor. This provides unidirectional torque as shown in this graph. The merits of this one phase winding 2 pulse brushless permanent magnet motor, the winding utilization is better, the torque developed is more uniform, the transistor utilization is less, and the circuit needs 3-wire DC supply. Next circuit, 2-phase winding and 2 pulse brushless permanent magnet DC motor. So in this type, the stator has 2 phase windings and they are displaced by 180-degree electrically. So this is similar to that of the one phase, 2-phase brushless permanent magnet motor, whereas it requires 2 phase windings. The torque waveforms of the 2 phase windings are shown and the resultant torque waveform is obtained. Merits, the torque developed is uniform. Demerits, utilization of transistors and winding is less. Fourth one, 3-phase winding and 3-phase 3-pulse brushless permanent magnet motor. The stator has 3-phase winding and its axes are displaced by 120-degree electrical apart. Each phase winding is controlled by a semiconductor switch and it is operated depending upon the position of rotor and it requires 3 position sensors. Merits of this 3-phase winding 3-pulse brushless permanent magnet motor, the torque developed here is better and the demerits are Utilization of winding and devices are less. Cables with rotor position sensor should be properly connected. Next one, three-phase 6-pulse brushless permanent magnet motor. So this circuit is the most widely used circuit. It has three-phase windings, WA, WB and WC, and six switches. The stator windings can be either star connected or delta connected. It requires 6 position sensor, and usually 120-degree or 180-degree conduction is adopted here. And this circuit produces unidirectional torque in all the three-phase winding excitation. The merits of this three-phase winding and 6-pulse circuit: the utilization of winding is better, the torque and current ripple components are less, and the demerits are the transistor utilization is less, 6 position sensors are required. So this session we have discussed about the different types of drive circuits used in brushless permanent magnet DC motor. Thank you everyone.